What if every choice you've ever made, every path taken or left behind, existed somewhere, playing out in a parallel reality? Picture a version of you who turned left instead of right, said yes instead of no, or pursued a dream they never dared to chase. This isn't just the stuff of blockbuster movies or wild speculation. Hidden in the archives of scientific history are theories that suggest the multiverse might be real, but not in the way you've been led to believe. Forget the cliches of identical Earths or mirror universes. The truth is far stranger, more nuanced, and buried beneath layers of overlooked ideas that mainstream science rarely talks about. For decades, the multiverse has been painted as a fantastical escape, a playground for storytellers. But what if it's actually a natural consequence of the laws that govern our universe? Theories from quantum mechanics to cosmic inflation hint at realities beyond our own, not as distant fantasies, but as inevitable outcomes of physics itself. Some of the brightest minds in history, figures whose ideas were sidelined or forgotten, proposed frameworks that could rewrite how we see existence. These aren't just abstract musings, they're mathematical possibilities with profound implications. Imagine uncovering a cosmic blueprint where every possible outcome of every event isn't just imagined but real. This journey isn't about wild guesses or sci-fi tropes. It's about revisiting the bold, often ignored ideas that challenge everything we think we know. From the eerie behavior of particles at the quantum level to the mind-bending expanses of an inflating cosmos, we'll piece together a vision of reality that's grander and more mysterious than you've ever considered. By the time we're done, you won't just see the multiverse differently, you'll question the very nature of the universe you call home. So let's step beyond the familiar and into the extraordinary. The answers are waiting, and they're far more surprising than you expect. Long before the multiverse became a pop culture phenomenon, ancient thinkers were already wrestling with the idea of infinite realities. Democritus, the Greek philosopher who first proposed atoms as the building blocks of matter, speculated that countless worlds might exist beyond our own, some thriving with life, others barren and empty. His vision wasn't born from wild imagination, but from a simple observation. If the universe is infinite, why should ours be the only one? Fast forward to the 20th century, and physics began catching up with philosophy. When quantum mechanics revealed that particles could exist in multiple states at once, a concept called superposition, scientists faced a paradox. How could reality remain undefined until someone observed it? Enter Hugh Everett III, a brilliant but underappreciated physicist who dared to ask, what if every possible outcome does happen, just in separate, branching realities? His many worlds interpretation wasn't science fiction. It was a mathematical solution to quantum weirdness, suggesting that the universe constantly splits into parallel versions of itself with every decision, every random event. Yet for decades, Everett's theory gathered dust. Mainstream science dismissed it as too extravagant, favoring the cleaner, more intuitive Copenhagen interpretation, which argued that quantum probabilities simply collapse into a single outcome when measured. The scientific community craved simplicity, and the idea of endless, unseen universes seemed like unnecessary baggage, but history has a way of circling back. Today, as physicists grapple with the fine-tuning of our universe, why its constants are so perfectly calibrated for life, the multiverse is experiencing a quiet revival. Cosmic inflation theory, which explains the rapid expansion of the early universe, suggests that new universes could bubble into existence endlessly, each with its own unique laws of physics. Even string theory, with its hidden extra dimensions, hints at a vast landscape of possible realities. What was once dismissed as metaphysical speculation is now a serious topic in physics conferences and peer-reviewed journals. The irony, these modern ideas share a striking resemblance to those ancient musings about infinite worlds, proof that sometimes the boldest truths are hiding in plain sight. The strangest thing about quantum mechanics isn't just that particles can be in two places at once, it's that this ambiguity might never actually resolve. Think of a coin suspended mid-flip, forever caught between heads and tails. Hugh Everett's many worlds interpretation takes this idea to its logical extreme. What if the coin never lands because both outcomes happen, just in separate, equally real branches of reality? This isn't some poetic metaphor. The math behind quantum mechanics doesn't favor one outcome over another. It treats every possibility as equally valid, unfolding simultaneously. When you measure a particle's position, you're not forcing it to pick a side. You're stepping into one of countless pre-existing threads where that particular result was always true. Take the famous double-slit experiment, where particles fired at a barrier create an interference pattern, as if they're waves spreading out and overlapping with themselves. The moment you try to observe which slit the particle passes through, the wave-like behavior vanishes. Copenhagen proponents say this proves measurement collapses the wave function, but Everett's interpretation flips the script. The interference pattern persists because every possible path the particle could take does happen, just in different universes. In one reality, it goes left, in another, right. The interference isn't destroyed, it's simply divided across worlds you can no longer see. What makes this more than just a philosophical curiosity is how it solves quantum mechanics' biggest headache, the observer effect. Copenhagen relies on a vague boundary between the quantum realm and the classical world, where observation somehow forces particles to choose, but Everett's model removes the mystery entirely. There's no collapse, no special role for consciousness, just an endlessly branching tree of causality where every quantum event spawns new realities. Recent experiments with entangled particles support this view. When particles remain correlated across vast distances, their behavior suggests they're responding to a reality where all outcomes coexist, even if we only experience one. Critics argue this is inelegant, a wasteful proliferation of universes, but consider the alternative. Our universe's laws appear fine-tuned to an almost impossible degree. If gravity were slightly stronger, stars would burn out too fast for life to emerge. If the cosmic expansion rate were tweaked, galaxies wouldn't form. The many worlds interpretation offers an elegant solution. Every possible configuration of physical constants exists somewhere in the multiverse. We just happen to inhabit the branch where conditions allowed us to be here to notice. Far from science fiction, this might be the most straightforward explanation physics has ever proposed for why our universe seems so improbably perfect. The irony, the theory once dismissed as extravagant now feels like the most honest answer quantum mechanics has ever given us. If quantum mechanics paints a picture of branching realities, cosmic inflation stretches that canvas across an unimaginable scale. Picture the early universe not as a single explosive event, but as a runaway expansion, an exponential stretching of space-time so violent and rapid that it would make the speed of light seem sluggish. This is the heart of Alan Gough's inflation theory, and it doesn't just explain why our universe is so uniform. It suggests something far more radical, that the Big Bang wasn't a one-time occurrence, but a single spark in an endless cosmic wildfire. When inflation began, tiny quantum fluctuations, those same unpredictable jitters that Everett's multiverse relies on, were stretched to astronomical sizes, becoming the seeds for galaxies and cosmic structures. But here's the twist: inflation doesn't stop everywhere at once. While our pocket of spacetime settled into the stable universe we know, other regions kept expanding exponentially, spawning new bubbles of reality like froth in a boiling pot. Each of these bubbles could have entirely different physics. Some might have stronger gravity, ripping stars apart before planets could form. Others might lack electromagnetism, leaving matter unable to assemble into complex structures. And a vanishingly small fraction, purely by chance, could have conditions just right for life. This isn't speculative fiction. The math behind eternal inflation is robust, and it solves a puzzle that's troubled cosmologists for decades: why our universe seems oddly fine-tuned for existence. If countless universes with random physical constants exist, it's no surprise we find ourselves in one where those constants allow galaxies, planets, and life. But how could we ever prove such a thing? The answer might be written in the oldest light we can see: the cosmic microwave background, the afterglow of the Big Bang. Subtle anomalies in this radiation, like unexpected cold spots or unusual patterns, could be cosmic bruises left by collisions with other bubble universes in the multiverse's foam. The wildest part: we might already have evidence. The Planck satellite's detailed maps of the microwave background reveal strange, large-scale asymmetries that defy standard explanations. Could these be echoes of neighboring universes brushing against ours? It's a tantalizing possibility, though far from confirmed. What's clear is that inflation's multiverse isn't just a thought experiment, it's a testable hypothesis, one that could reshape our place in the cosmos. We're not just living in a universe, we're floating in an ocean of them, each with its own story, its own laws, and perhaps its own version of this very conversation. String theory doesn't just rewrite the rules of physics, it reshapes the very fabric of reality into something far grander than we ever imagined. At its core, this framework suggests that the fundamental building blocks of the universe aren't particles, but tiny, vibrating strings. The way these strings oscillate determines everything from the mass of an electron to the strength of gravity. But here's where things get mind-bending. These vibrations can occur in an almost unimaginable number of configurations. Picture a cosmic piano with 10 to the power of 500 possible keys, each representing a unique universe with its own laws, its own dimensions, and its own version of physics. This is the landscape multiverse, a concept that turns the fine-tuning of our universe from a baffling coincidence into an inevitable outcome. If every possible configuration of physical constants exists somewhere in this vast landscape, it's no surprise we find ourselves in a universe where those constants allow stars, planets, and life. Leonard Susskind, one of string theory's pioneers, argues this isn't just a convenient explanation, it's the only one that doesn't require invoking sheer luck. The alternative, believing that out of all possible universes, ours just happened to win the cosmic lottery, critics push back, and their concerns aren't trivial. If the landscape multiverse contains more configurations than there are atoms in the observable universe, how could we ever test it? Science thrives on falsifiability, the ability to prove a theory wrong, and a multiverse that's eternally out of reach seems to defy that principle. But proponents counter with a provocative idea. What if the test isn't about seeing other universes, but about understanding why ours looks the way it does? The eerie precision of our physical constants, from the cosmological constant to the mass of the Higgs boson, might be indirect evidence of a deeper, vaster reality. String theory's landscape doesn't just challenge our place in the cosmos, it redefines what science can even ask. For centuries, physics sought a single, elegant equation to explain everything. Now we're staring at a reality where everything might include infinite variations, each equally valid. It's a humbling thought. Our universe isn't the masterpiece. It's one brushstroke in a canvas so large we'll never see the whole picture. Yet in that uncertainty lies a strange comfort. If the multiverse is real, then every possible version of existence isn't just imagined, it's out there, vibrating silently in the dark. Imagine if the universe you see around you, the stars, the planets, even your own hands, wasn't truly three-dimensional, but a projection from a flat, two-dimensional surface. This isn't the plot of a sci-fi novel. It's the holographic principle, a radical idea born from an unlikely place, the study of black holes. When physicists calculated the maximum information a black hole could contain, they stumbled onto something bizarre. The data didn't scale with the volume inside the black hole, but with the area of its event horizon. In other words, all the information needed to describe a 3D space could be perfectly encoded on a 2D boundary. This discovery sent shockwaves through theoretical physics. If true for black holes, could it apply to the entire universe? The holographic principle suggests that everything we perceive, every particle, every force, even our own thoughts, might be pixels on a cosmic screen, a shadow play cast from a flat reality we can't see. Think of it like a movie projected onto a theater wall. The images appear to have depth, but they're actually just light manipulated by a flat film. If our universe works this way, then the multiverse could be an even stranger place. Not just parallel realities, but parallel projections, each encoded on their own distant surfaces. But what if reality isn't just encoded? What if it's programmed? Philosopher Nick Bostrom's simulation hypothesis takes this idea further. If advanced civilizations could one day create hyper-realistic simulations of their ancestors' simulations so detailed that the simulated beings have conscious experiences, then statistically, the odds suggest we're more likely to be those simulations than the original civilization. It's a modern twist on Descartes' evil demon, updated for the digital age. In this scenario, the multiverse wouldn't be a natural phenomenon, but a vast computational experiment, with each universe running as a separate instance on some unfathomable hardware. The implications are dizzying. If we're in a simulation, the so-called laws of physics might just be the rules of the program, arbitrarily set by the simulators. Glitches in quantum behavior, like particles tunneling through barriers or existing in two places at once, could be processing artifacts' cosmic lag in a system rendering trillions of realities at once. Even the fine-tuning of our universe's constants might have a mundane explanation. They were debugged until life could run without crashing. Skeptics argue these ideas are untestable, more metaphysics than physics. But some scientists disagree. If the universe is a hologram, there should be a fundamental limit to how finely space can be divided, a pixel size for reality itself. Experiments with gravitational wave detectors and quantum entanglement are hunting for this graininess, searching for distortions that might betray the underlying code. As for simulations, researchers have proposed looking for mathematical shortcuts or repeating patterns in cosmic rays, signs that the universe is running on finite processing power. Whether projection or program, these theories force us to confront an unsettling question. What is real? If the multiverse is a hologram, then every parallel reality is just another image on the same cosmic film. If it's a simulation, then every branching timeline is a subroutine in an alien computer. Either way, the boundaries of existence are far blurrier than we ever imagined. And that's the most fascinating part. These aren't just thought experiments, they're challenges to the very foundation of what we call reality. pushing us to wonder not just where we are, but what we are. The answers, if they exist, might rewrite not only science but philosophy, identity, and the meaning of existence itself. Dark matter is the universe's most frustrating riddle. We can't see it, touch it, or detect it directly, yet without it, galaxies would fly apart and cosmic structures would never have formed. For decades, scientists have searched for particles that could explain this invisible scaffold. But what if the answer isn't hiding in our universe at all? Some of the boldest theories suggest dark matter might be the first tangible evidence of something far stranger, parallel realities brushing up against ours. Imagine a hidden dimension curled up so tightly that it's imperceptible to us, like an ant walking along a telephone wire, unaware of the vast world stretching above and below. String theory proposes that these extra dimensions could exist, folded into the fabric of space-time at scales 1 billion times smaller than an atom. But here's the twist: what if some of those dimensions aren't just tiny? What if they're vast, housing entire universes with their own stars, planets, even civilizations? In this scenario, dark matter might not be exotic particles in our universe, but ordinary matter from a neighboring one, drifting just out of reach. Gravity, the only force thought to traverse these dimensions, could be tugging on our galaxies from the other side. This idea isn't pure speculation. Certain models, like the brain world theory, suggest our universe is a three-dimensional membrane, or brain, floating in a higher dimensional space. Other brains could hover nearby, separated by a cosmic gulf we can't cross. Matter on those brains would be invisible to us, but its gravitational pull would still leak through, like a shadow cast through frosted glass. That shadow, some physicists argue, could be the dark matter we've been chasing all along. The implications are staggering. If true, the missing 85% of the universe's mass isn't missing at all. It's just sitting in another reality, forever out of view. Even more tantalizing, this could mean the multiverse isn't some distant abstraction, but something actively shaping the cosmos we see every day. The galaxies spinning too fast, the gravitational lensing with no visible source. These anomalies might be fingerprints from a universe next door. So how do we test such a radical idea? The answer might lie in the world's most powerful particle smasher. The Large Hadron Collider could, in theory, produce particles that briefly kick into these extra dimensions, vanishing from our detectors in a way that defies standard physics. Other experiments, like searches for faint gravitational waves or anomalous energy losses in particle collisions, might reveal hidden interactions with unseen realms. The most thrilling possibility: dark matter could be the tip of a multidimensional iceberg. If we're detecting the gravitational echoes of another universe, what else might be lurking just beyond the edge of perception? The answer could rewrite not just cosmology, but our very understanding of reality. And the strangest part, the evidence might have been there all along, woven into the invisible threads holding our universe together. If numbers and equations aren't just human inventions but the very bones of reality, then the multiverse isn't just vast, it's infinite in the most literal sense. This is the heart of Max Tegmark's mathematical universe hypothesis, a theory so radical it blurs the line between physics and metaphysics. Imagine every possible mathematical structure, from the simplest geometric shapes to the most convoluted equations, not as abstract ideas but as actual physical universes. A cosmos where gravity operates in 11 dimensions exists. A reality where time loops back on itself like a Möbius strip also exists. Even universes with no stars, no atoms, no recognizable physics at all would be out there, not as hypotheticals, but as concrete places, simply because the math allows them to be. At first glance, this seems like an extravagant leap, but consider how eerily effective mathematics has been at describing our universe, from the orbits of planets to the behavior of subatomic particles. Einstein famously marveled at this, asking why math, a product of human thought, should so perfectly match the workings of nature. Tegmark's answer flips the question on its head. Maybe the universe isn't described by math, maybe it is math. In this view, the reason physics obeys elegant equations isn't because we've uncovered some deep truth, but because reality is, at its core, a mathematical object. This leads to a staggering implication. Our universe isn't special. It's just one page in an endless textbook of mathematical possibilities. So why does it feel so finely tuned for life? Enter Anthropic reasoning, the idea that we can only observe a universe compatible with our existence. If countless universes exist with random physical laws, we'd inevitably find ourselves in one where those laws allow galaxies, planets, and conscious observers. The others, they're still out there, filled with phenomena beyond our imagination, but devoid of anyone to notice. Critics argue this hypothesis is untestable, more philosophy than science. But Tegmark counters that it makes specific predictions. If reality is purely mathematical, then at the deepest level, there should be no unnecessary baggage, no arbitrary constants or unexplained parameters. Everything should reduce to pure structure. Intriguingly, this aligns with trends in modern physics, where theorists strive to eliminate free parameters from fundamental equations. Even the nature of time and space might emerge from deeper mathematical relationships, like temperature emerging from the motion of atoms. The real mind bender isn't just the scale of this multiverse, but what it says about existence itself. If every mathematical possibility is real, then somewhere, there's a universe where the digits of pi rearrange into a perfect circle, or where 2 plus 2 equals 5. These aren't logical errors, they're alternate realities with their own consistent rules. Our intuition screams that this can't be right, but intuition evolved in a world of medium-sized objects moving at slow speeds. At the cosmic scale, nature has repeatedly shown us that reality doesn't care what feels plausible. What makes Tegmark's hypothesis so compelling isn't just its audacity, but its simplicity. It doesn't require inventing new physics or hidden dimensions, just the recognition that math, the language we've used to decode the universe, might be the universe itself. Whether this is the ultimate truth or a beautiful dead end, one thing is certain. It forces us to confront the possibility that reality is far stranger and far more abundant than we ever dreamed. And that's the most exciting part. The multiverse isn't just a scientific idea, it's a mirror reflecting back all the wild, uncharted possibilities of existence. The fine-tuning of our universe is so precise it feels deliberate, like someone dialed in the numbers just right. If gravity were even slightly stronger, stars would burn out too fast for planets to form. If the weak nuclear force were marginally weaker, hydrogen wouldn't fuse into helium, and the cosmos would be a lifeless sea of atoms. These aren't minor quirks, they're cosmic necessities, and the odds of them aligning by chance are astronomically small. Enter the anthropic principle, the idea that the universe must appear hospitable to us because, well, we're here to notice. It's not that the laws of physics were designed for life, it's that life can only arise in a universe where those laws allow it. But here's where the multiverse flips the script. If countless universes exist, each with randomly shuffled physical constants, most would be barren wastelands, cosmic dead ends where matter never clumps into galaxies or atoms never bond into molecules. A rare few, purely by statistical luck, would land in the Goldilocks zone where life becomes possible. We're not in a special universe, we're in the only kind of universe where beings like us could ever ask why it's so special. It's a cosmic version of survivorship bias. The winners are the ones left standing to tell the tale. Critics push back hard, calling the multiverse a solution to fine-tuning, they argue, is like explaining a mystery by inventing infinite mysteries. If every possible universe exists, then nothing is truly explained, just diluted in a sea of alternatives. Physicist Paul Davies famously compared it to invoking an infinite number of monkeys typing Shakespeare. Sure, one of them eventually gets it right, but that doesn't make the result any less astonishing. The real puzzle, he claimed, isn't why our universe works, it's why any universe works at all. Supporters counter with a provocative thought experiment. Imagine a fish in a pond marveling at how perfectly the water's depth, temperature, and chemistry suit its existence. To the fish, the pond seems miraculously fine-tuned until it learns of oceans, lakes, and rivers. The multiverse, in this view, is the ocean. Our universe isn't a lucky accident. It's an inevitable outlier in a vast ensemble where every possible environment exists. The fine-tuning problem doesn't vanish, it's reframed. Instead of asking why this universe is life-friendly, we ask why life-friendly universes are possible at all. The debate reveals a deeper tension in how we seek explanations. Science thrives on simplicity, the idea that a few fundamental laws can unpack the cosmos. The multiverse, with its infinite variations, feels messy by comparison. But maybe messiness is the price of truth. After all, evolution seemed messy to those who believed life was designed, until we saw how complexity could emerge from simple rules and time. The multiverse might follow the same path. An idea that starts as a controversial placeholder, then gradually becomes the only framework that fits the data. For now, the fine-tuning question lingers, a riddle wrapped in probabilities. But whether the multiverse is the ultimate answer or just a stepping stone, one thing is clear: our universe's delicate balance is no illusion. It's a clue, one that points beyond the edges of reality as we know it, into the uncharted territories of existence itself. Time feels like the most reliable constant in our lives, always ticking forward, never reversing. But what if this steady march of cause and effect isn't a universal rule, just a quirk of our particular corner of reality? The mystery of time's arrow begins with entropy, the measure of disorder in a system. In our universe, entropy always increases, like a shattered glass that never spontaneously reassembles. This irreversible flow gives us memories of the past but not the future, creating the illusion that time has a fixed direction. Yet the laws of physics themselves are time-symmetric. They don't care if time runs forward or backward. So why does it feel so one-way? Some physicists propose a startling answer. Our experience of time might be a side effect of the multiverse. Imagine a cosmic tree where every quantum decision spawns new branches, each with its own timeline. In most of these branches, entropy increases just like in ours. But statistically, there must also be rare offshoots where entropy decreases, where smoke pours back into a cigarette, or eggs unscramble themselves. We don't witness these anomalies because conscious observers can only exist in branches where entropy flows correctly, creating stable environments for life. In other words, we don't remember the future because we're stuck in a universe where that's impossible. This idea, known as the Anthropic multiverse, flips traditional thinking on its head. Time isn't an absolute river flowing through all existence. It's more like a local weather pattern, varying from one reality to the next. In some branches, time might loop like a Möbius strip, with events repeating endlessly. In others, it could fracture into disconnected moments, like a film reel with missing frames. Even stranger, certain quantum gravity models suggest that near a black hole's singularity, time might dissolve entirely, becoming space-like. If true, the arrow of time isn't a fundamental feature of the cosmos. but an emergent property like temperature arising from the motion of atoms. But here's the paradox: if time's flow isn't universal, how do we explain the unshakable consistency of cause and effect in our daily lives? Why does every experiment, from baking a cake to launching a rocket, obey the same temporal rules? The answer might lie in the sheer improbability of low entropy states. Universes where time behaves erratically are like cosmic lottery losers. They might exist, but they're too disordered to support observers. We find ourselves in a branch where conditions are just right for stability, making the illusion of uniform time feel inescapable. The implications ripple far beyond physics. If time is a local phenomenon, free will takes on new dimensions. Every choice you make could spawn realities where time flows differently, rendering notions of destiny and determinism obsolete. Even the Big Bang might not be a singular beginning, but one fluctuation in an eternal sea of universes, each with its own temporal signature. The greatest irony, the very thing that makes our existence possible, time's relentless forward march, might be the clearest clue that we're part of something infinitely larger, where the rules we take for granted are just one variation in a multiverse symphony. The next time you check your watch, remember, you're not just measuring hours, you're reading a fingerprint left by realities beyond imagining. Quantum immortality sounds like the ultimate cheat code for existence, a guarantee that you'll never truly experience death because your consciousness always jumps to a reality where you survive. This bizarre idea emerges from the many worlds interpretation, where every possible outcome of a quantum event spawns a new universe. If you step in front of a bus, there's a branch where you die instantly, but also one where a last-second stumble saves you, or where the bus swerves, or where it was all just a dream. Quantum immortality suggests your awareness only follows the paths where you're still alive, creating the illusion that you're impossibly lucky. At first glance, this seems like a philosophical sleight of hand, but it forces us to confront uncomfortable questions. If consciousness is tied to survival, does that mean we're all trapped in an endless recursion of near misses, blind to the versions of ourselves that didn't make it? The theory gained traction when physicists like Max Tegmark pointed out that under many worlds, the probability of observing a universe where you don't exist drops to zero. You can't witness your own death because by definition there's no you left to observe it. Critics argue this is a misuse of probability, a confusion between observing outcomes and being outcomes. Just because some branch of the multiverse contains your survival doesn't mean your consciousness magically teleports there. Consciousness, they say, isn't a cosmic cursor hopping between timelines. It's a local phenomenon tied to the brain's physical state. When your brain stops functioning in one universe, that's the end of the story for that version of you, regardless of what happens elsewhere. Yet the idea persists because it challenges our assumptions about identity. If every decision splinters reality, which you is the real one, are you the sum of all your possible selves, or just the thread of awareness you're experiencing now? Quantum immortality pushes this further, suggesting that subjective experience might be weirder than we think, less a continuous stream, and more a spotlight hopping between stages in an infinite multiverse theater. The most haunting implication isn't about cheating death, but about isolation. If the theory holds, everyone you've ever known who died, friends, family, historical figures, didn't vanish. Their consciousness simply continued in branches you can no longer access. You're left in a reality where they're gone, while somewhere their awareness carries on in worlds where you were the one who didn't make it. It's a lonely thought, and one that stretches the limits of what science can ethically test. For now, quantum immortality remains a fringe hypothesis, more thought experiment than testable theory. But it lingers because it exposes the strangeness lurking at the intersection of physics and consciousness. Whether it's true or not, it forces us to ask, what is experience in a multiverse where every possibility plays out? The answer might not just redefine life and death, it could reshape what it means to exist at all. Long before equations or particle colliders, humanity was already dreaming of other worlds. Take Hindu cosmology, where countless universes float like bubbles in an endless cosmic ocean, each with its own gods, its own laws, and its own cycle of creation and destruction. The Rig Veda, written over 3,000 years ago, describes these parallel realms as Brahmandas, cosmic eggs that hatch, expand, and eventually dissolve, only for new ones to take their place. It's a vision eerily reminiscent of modern inflation theory's bubble universes, where new pockets of spacetime constantly bud off from an eternally inflating cosmos. Then there's the Norse Yggdrasil, the great world tree whose roots and branches connect 9 distinct realms, from Asgard's shining halls to the icy wastes of Niflheim. These aren't just separate lands, they're layers of reality, each operating by its own rules. The Vikings didn't have quantum field theory, but their myths captured something profound: the idea that existence isn't a single stage, but a tapestry of interwoven dimensions. Even the Aboriginal Dreamtime speaks of a timeless, parallel reality where ancestors shaped the world, a concept that resonates with the holographic principle's suggestion that our universe might be a projection from a deeper, hidden plane. What's striking isn't just that these cultures imagined alternate realities, but how they imagined them. The Hopi people of North America spoke of past worlds destroyed and rebuilt, each with its own physical laws, a striking parallel to the cyclic universe model in modern cosmology. Meanwhile, Buddhist texts describe Sahasra Lokadhatu, a vast array of world systems, each with its own Buddha teaching a path to enlightenment. These aren't just stories, they're sophisticated frameworks for grappling with plurality, suggesting that the human mind has always sensed there's more to reality than meets the eye. So were ancient seers tapping into some universal truth, or were they simply using myth to explain the unexplainable? The answer might be both. Without telescopes or microscopes, early cultures relied on intuition and metaphor to make sense of the cosmos. When the night sky felt infinite, or dreams offered glimpses of impossible places, multiverses became a natural way to articulate that boundlessness. But here's the twist: modern physics keeps circling back to similar ideas. The quantum multiverse, the inflationary bubble universes, the brain worlds of string theory, they all echo those ancient intuitions, as if science is finally catching up to something storytellers knew all along. The real lesson here isn't that mythology predicted particle physics. It's that humans across time and culture have repeatedly stumbled upon the same profound suspicion: that reality is bigger, weirder, and more interconnected than it appears. Whether through sacred texts or supercomputers, we've always been reaching for the same truth: that the universe we see might just be one thread in an infinite tapestry. And that's the most humbling part. After millennia of searching, the oldest stories and the newest science might finally be telling the same story. Hollywood loves the multiverse, but it often treats it like a cosmic theme park where characters swap hats with their alternate selves or fistfight evil versions of themselves across dimensions. Films like Everything Everywhere All at Once and Doctor Strange turn parallel realities into playgrounds where the rules bend to serve the story. And why not? It's thrilling to imagine slipping into a universe where you're a rock star chef or a pirate queen. But here's the catch: real physics doesn't work like a scriptwriter's wildest dreams. The true multiverse isn't a place where you can high-five your doppelganger or borrow a time-traveling DeLorean. It's something far more fascinating and far less convenient. Take the many worlds interpretation. In reality, branching universes don't mean you can hop between them like subway lines. Every quantum decision spawns new realities, but they're sealed off from one another, diverging forever like strands of spider silk in the wind. There's no portal, no magic spell, no handy remote control to switch timelines. Even if alternate versions of you exist, you'll never meet them, trade secrets, or team up to save the cosmos. The laws of physics don't just discourage interdimensional tourism, they forbid it. And then there's the pop culture trope of evil twins. In a genuine multiverse, most alternate versions of you wouldn't be mustache-twirling villains or heroic upgrades. They'd be subtly different. Maybe you took a different job, moved to a different city, or had an extra cup of coffee this morning. The really wild branches, where history unfolded completely differently, would be so alien that you might not even exist there. No evil empires, no dystopian wastelands, just a quiet, infinite tapestry of possibilities, most of them mundane. Yet for all its inaccuracies, pop culture's obsession with the multiverse serves a vital purpose. It keeps the conversation alive. When Rick and Morty turns dimension hopping into a punchline, or Loki turns timelines into a bureaucratic nightmare, it's not teaching physics, but it is sparking curiosity. These stories act as gateways, tempting audiences to ask, could any of this be real? And that's where science steps in. The more we see the multiverse in movies, the more we demand real answers. The irony, some of the most outlandish multiverse tales accidentally stumble onto kernels of truth. Everything, everywhere, all at once's idea of tapping into alternate versions of yourself to gain their skills. That's not entirely unlike quantum superposition, where particles borrow properties from all possible states until observed. Interstellar's tesseract, where time becomes a physical dimension. It echoes physicist Kip Thorne's real theories about higher dimensional spacetime. Even Doctor Strange's mirror dimension isn't that far from the holographic principle's suggestion that our 3D world might be a projection from a 2D surface. So how do we separate fact from fiction? Start by embracing the weirdness but grounding it in science. The multiverse isn't less exciting because you can't visit it. It's more exciting because it's real. Every time a particle behaves unpredictably, every time the cosmos seems oddly fine-tuned, we're glimpsing the edges of something vast and mysterious. Pop culture's fantasies may bend the rules, but they remind us of the essential truth. Reality is stranger than we think, and that's the real magic. Testing the multiverse might sound like trying to catch smoke with your bare hands. How do you gather evidence for realities you can't touch, see, or visit? Yet scientists are turning this philosophical puzzle into a detective story, hunting for cosmic breadcrumbs that could lead to the unimaginable. One promising clue lies in the oldest light in the universe, the cosmic microwave background, that faint afterglow of the Big Bang. Imagine it as a cosmic fingerprint stretched across the sky. Hidden in its subtle patterns might be the telltale wrinkles of a collision, an ancient crash between our universe and another bubble of spacetime. These bruises would appear as unusual cold spots or swirling asymmetries, like scars left by a close encounter with another reality. But the cosmic microwave background isn't the only crime scene. Particle physics offers another angle. If extra dimensions exist, those hidden folds in spacetime, some multiverse theories rely on then high-energy collisions in machines like the Large Hadron Collider could produce particles that briefly vanish, slipping into these unseen realms. It's like throwing a ball against a wall and watching it disappear mid-air, only to reappear a moment later. These tiny anomalies wouldn't just hint at parallel universes, they'd rewrite our understanding of gravity, matter, and the very fabric of existence. Then there's the mystery of dark flow, an eerie phenomenon where entire galaxy clusters seem to drift in the same direction, as if tugged by something massive beyond the observable universe. Could this be the gravitational pull of a neighboring cosmos, a vast structure lurking just past the edge of our cosmic horizon? The data is controversial, but the idea is tantalizing. What if the multiverse isn't just out there, but actively pulling on us? Skeptics argue these searches are like diagnosing a ghost by its shadow, too indirect, too speculative. But science has a history of detecting the undetectable. No one's ever seen an electron, yet we're certain they exist. Black holes were once dismissed as mathematical oddities until we heard their collisions through gravitational waves. The multiverse might follow the same path, an idea so radical it seems untestable until someone cracks the code. The real breakthrough may not come from a single eureka, a moment, but from a convergence of clues, a pattern of anomalies across cosmology, quantum mechanics, and particle physics that together paint a picture too coherent to ignore. Until then, the hunt continues, not as a wild gamble, but as the boldest kind of science, exploring the edges of the knowable, one experiment at a time. Occam's razor cuts through scientific debates like a scalpel. Its principle is clear. When faced with competing explanations, the simplest one is usually correct. On the surface, the multiverse seems to violate this rule spectacularly. Why conjure an infinite number of unseen universes just to explain why ours looks so finely tuned? Critics compare it to blaming missing socks on an invisible army of laundry gnomes, a creative solution, but hardly the most straightforward. If science thrives on parsimony, then the multiverse feels like a cosmic cheat code, dodging hard questions by invoking endless alternatives. But dig deeper and the story gets messy. What counts as simple isn't always obvious. A single, finely tuned universe might seem tidy until you realize it demands an inexplicable coincidence. Why these constants? Why these laws? Without the multiverse, you're left with two equally unsatisfying options. Either our universe's perfection is a staggering fluke, or some unknown force hand-picked these parameters. Both require their own leaps of faith. The multiverse, for all its extravagance, offers a way out. If every possible configuration of physics exists somewhere, then no fine-tuning needs explaining. We're just in the slice of reality where life could arise. The real tension here isn't about simplicity, it's about elegance. Physicists don't just want answers. They want answers that feel inevitable, where the pieces lock together without forcing. The Copenhagen interpretation of quantum mechanics, for example, seems simple because it avoids parallel worlds, but it introduces the vague, ad hoc collapse of the wave function, a process no one fully understands. In contrast, the many worlds interpretation removes this kludge by letting every outcome play out somewhere. No collapse, no observer magic, just pure deterministic branching. Suddenly, the multiverse looks less like a complication and more like a trade-off. More universes, but fewer arbitrary rules. This debate reveals a deeper rift in how science weighs explanations. Is simplicity about minimizing entities, like trimming the number of universes down to one? Or is it about minimizing assumptions, like avoiding unexplained fine-tuning? Even Occam's razor has its limits. Newton's laws seemed perfectly simple until Einstein showed they were approximations of a stranger, grander reality. Sometimes what looks like needless complexity from one angle is the cleanest solution from another. The multiverse forces us to ask, is reality obligated to fit our aesthetic preferences? If the math points to infinite universes, does it matter whether we find the idea tidy or not? History suggests that when science clashes with intuition, intuition usually loses. Atoms, black holes, quantum entanglement. All seemed absurd until evidence made them unavoidable. The multiverse might follow the same path, an idea that starts as a philosophical last resort, then becomes the only framework that makes the numbers add up. Until then, the razor keeps cutting, not toward simplicity, but toward whatever truth, however messy, lies waiting. Black holes have always been cosmic enigmas, regions where gravity is so intense that not even light can escape. But what if their darkness hides something even more extraordinary? Some physicists speculate that beyond the event horizon, past the crushing grip of tidal forces, the singularity at a black hole's heart might not be an endpoint at all. Instead, it could be a bridge or wormhole stitching together our universe with another. The math behind this idea traces back to Einstein and Rosen, who theorized that singularities might connect distant regions of spacetime. In this scenario, falling into a black hole wouldn't obliterate you. It would catapult you into an entirely new cosmos. Of course, reality is far messier than theory. The forces near a black hole singularity would stretch and compress anything crossing its threshold into what scientists grimly call spaghettification. Even if another universe lies on the other side, no known material or life form could survive the trip intact. But here's where things get interesting. If the black hole is rotating, as most are, the singularity might not be a point but a ring. A theoretical structure known as a Kerr singularity. Ring singularities could, in principle, create stable wormholes, offering a smoother passage through the space-time fabric. The catch: you'd need some form of exotic matter with negative energy to hold the wormhole open, a substance we've never observed in nature. The wildest implication isn't just about travel, it's about creation. Some models suggest that the extreme conditions inside a black hole could trigger the birth of an entirely new universe with its own laws of physics. This idea, known as black hole cosmology, proposes that our own Big Bang might have been the singularity of a black hole in another reality. If true, every black hole in our universe could be incubating new cosmic realms, invisible to us but just as real. It's a dizzying thought, universes nesting inside one another like Russian dolls, each birthed from the collapse of a star in some higher dimensional parent cosmos. So how do we test such a mind-bending idea? Direct observation is impossible. No signal can escape a black hole to tell us what's inside. But physicists look for indirect clues, like subtle distortions in the light from objects orbiting black holes, which might hint at hidden structures. Others study the holographic principle, which suggests that information falling into a black hole isn't destroyed but encoded on its surface, like a cosmic QR code. If that's true, the singularity might not be a destructive pit but a transformative gateway, rewriting the rules of existence itself. Whether black holes are cosmic killers or creators, one thing is certain: they challenge our deepest assumptions about reality. They're not just dead ends, they're frontiers, pushing us to rethink what's possible in a multiverse where even the most violent phenomena might hide doors to other worlds. And that's the real beauty of these ideas. They remind us that the universe is stranger than we dare imagine, and the answers we seek might lie in the last place we'd think to look, the abyss itself. The silence of the cosmos is deafening. With billions of galaxies, each containing billions of stars, the universe should be buzzing with alien civilizations, yet we've found no signals, no artifacts, no signs of life beyond Earth. This eerie absence is the heart of the Fermi Paradox, and it gnaws at one of science's biggest assumptions: that life is a natural, even inevitable, outcome of cosmic evolution. But what if we're asking the wrong question? Instead of wondering why we haven't found aliens, perhaps we should ask why we exist at all. Enter the multiverse. If countless universes exist, each with randomly determined physical constants, then most would be barren wastelands, cosmic dead ends where atoms never form molecules, stars never ignite, or gravity crushes all complexity before it can begin. In this view, our universe isn't special because life is common. It's special because life is possible here against astronomically slim odds. The Fermi Paradox might not be a puzzle to solve, but a clue pointing to a vaster reality. We're not just alone in this universe. We might be alone in the only kind of universe where beings like us could ever ask the question. Think of it like a cosmic version of survivor bias. Imagine walking into a casino where 1,000,000 slot machines are spinning at once. Most will land on lose, but purely by chance, a handful will hit the jackpot. From the perspective of those lucky winners, their success seems destined, but the truth is, they're just the inevitable outliers in a sea of failure. Now scale that up to universal proportions. If the multiverse is real, then the reason we don't see aliens isn't because they're hiding. It's because in almost every other universe, the conditions for life never line up. We're not the rule, we're the exception. Critics argue this explanation is a cop-out, a way to dodge the hard work of searching for extraterrestrial intelligence by invoking infinite unseen realities. After all, if the multiverse can explain anything, does it really explain anything at all? But supporters counter with a compelling point, the alternative, that our universe's life-friendly constants are a 1 in a trillion fluke, is even harder to swallow. The multiverse doesn't erase the mystery of the Fermi Paradox. It reframes it, turning "where is everybody" into "why does anywhere allow somebody to exist?" There's another twist. Even in the rare universes where life emerges, intelligence might be a fleeting accident. Earth's history shows how fragile the path to complexity can be. If the asteroid that wiped out the dinosaurs had missed, mammals might never have risen to dominance. If Earth's magnetic field were weaker, solar radiation would have sterilized the surface. In a multiverse, most habitable worlds could be stuck in perpetual microbial stagnation, or see civilizations blink out before they ever reach the stars. We might not just be in a rare universe, we might be in a rare timeline within that universe. The unsettling truth, the multiverse doesn't solve the Fermi Paradox so much as deepen it. Instead of a single, silent cosmos, we're faced with infinite silent cosmoses, most of them eternally dark. But that darkness isn't empty. It's the shadow cast by something far grander, a reality so vast that even the absence of life becomes evidence of its existence. And that's the ultimate irony. The silence we've been straining to break might be the loudest clue yet that we're part of something unimaginably bigger. Simulated universes turn reality into a hall of mirrors. What if everything we see, touch, and experience is just lines of code in some unfathomable supercomputer? The idea isn't as far-fetched as it sounds. Tech mogul Elon Musk once quipped that the odds we're living in base reality are 1 in billions, pointing to the rapid advancement of our own simulation technology. If civilizations just a few centuries ahead of us can create virtual worlds indistinguishable from reality, why wouldn't someone else have already done it? Philosopher Nick Bostrom formalized this logic in his famous simulation argument. If any advanced society ever runs ancestor simulations, digital recreations of their past, then statistically, simulated minds would vastly outnumber organic ones. The unsettling conclusion, you're probably one of them, but who would build such a thing? Motivations range from the mundane to the cosmic. Maybe future historians simulate universes to study cultural evolution, watching civilizations rise and fall like lab mice in a digital terrarium. Or perhaps it's entertainment, a hyper-advanced version of a video game where conscious beings are NPCs unaware they're characters in someone else's story. There's a darker twist too. What if we're someone's abandoned prototype, a glitchy universe left running in the background while our creators moved on to better projects? The most haunting possibility, we're not the main simulation at all, but a subroutine in a larger process, like cells in a body unaware of the organism they compose. This isn't just speculative fiction. Physicists have proposed real-world tests for the simulation hypothesis. One approach looks for pixelation in reality, tiny, fundamental limits to how finely space can be divided, like the resolution of a digital screen. If the universe is rendered on a cosmic GPU, there should be a smallest possible distance where smoothness breaks down into discrete chunks. Another hunt is for mathematical shortcuts in the laws of physics signs that the simulators cut corners to save processing power. For example, quantum mechanics already suggests particles don't have definite properties until observed, as if the universe is lazily rendering only what's being looked at. Even the speed of light could be a built-in limit to prevent the simulation from overloading. The existential weight of these ideas is crushing. If we're living in a simulation, does anything we do matter? The answer might hinge on why we were created. In a research simulation, our struggles could be someone's data points. In an entertainment scenario, our triumphs might be scripted plot twists. But here's a paradox. If the simulators gave us free will, or the illusion of it, then our choices still feel real to us. The pain, joy, and meaning we create exist as experiences regardless of their substrate. A simulated Shakespeare still writes Hamlet. A simulated Einstein still unlocks relativity. The art and science don't lose their beauty just because they're made of information instead of atoms. Could we ever escape? The Matrix popularized the idea of a red pill rebellion, but real physics offers no backdoor. If the simulation is nested inside a higher reality with different laws, breaking out might be like a video game character trying to crawl into the player's keyboard, logically impossible. Yet some theorists speculate that if we ever discovered the simulation source code, we could hack it. Imagine manipulating the fundamental constants like sliders in a cosmic settings menu, or even uploading our consciousness into the creator's world. Of course, this assumes they'd allow such interference. A truly advanced civilization might have safeguards, firewalls between realities that make intrusion as futile as an ant trying to reason with a hurricane. The simulation hypothesis forces us to confront the oldest question in philosophy: what is real? It doesn't just blur the line between science and metaphysics, it erases it. Whether we're in a simulation or not, the universe behaves as if it could be one, and that's a revelation in itself. Our reality, whatever its origin, is built on rules that can be studied, tested, and understood. In that sense, the search for truth remains unchanged. The only difference is the scale of the mystery and the humbling possibility that every discovery we make might just be part of someone else's design. Time travel isn't just a sci-fi trope, it's a philosophical minefield that forces us to ask, how does the universe handle paradoxes? Take the infamous grandfather paradox. If you went back in time and prevented your grandfather from meeting your grandmother, you'd logically erase your own existence. But if you never existed, who went back to change the past? It's a closed loop of impossibility that seems to break causality itself. The multiverse offers an elegant escape hatch. Instead of creating a paradox, every time-traveling intervention could spawn a new, self-consistent timeline. One where your actions alter history without erasing your original reality. You don't vanish, you just become a stranger in a world where your past never happened. This idea isn't just narrative convenience, it's rooted in real physics. Hugh Everett's many worlds interpretation, originally devised to explain quantum mechanics, suggests that every decision point fractures reality into parallel branches. Apply that to time travel, and suddenly, altering the past isn't rewriting history, it's stepping onto a new branch of the cosmic tree. In one timeline, your grandparents meet and produce your family line. In another, their story diverges and someone else's future unfolds. The original you isn't erased, you're just no longer part of that new world's causal chain. It's a solution so clean that even physicists like David Deutsch have argued it's the only way time travel could logically work. But here's the catch. If time travel creates alternate timelines, could you ever return to your original reality? Most theories say no. Once you've branched off, you're stranded in the new timeline, like a raft adrift in a cosmic river. This raises eerie questions about identity and consequence. If you fix a tragic event in the past, the version of you from the original timeline never benefits. They continue suffering in their unchanged world. Your actions don't undo history, they abandon it. This isn't the triumphant time travel of movies. It's a lonely, one-way trip into uncertainty. The multiverse approach also challenges our instinct that time is a fixed thread. If every possible past and future exists simultaneously, then changing history is a misnomer. All versions already exist, you're just choosing which one to experience. This mirrors quantum mechanics, where particles exist in superpositions until observed. Could time travelers be like quantum observers, collapsing infinite possibilities into a single lived reality? It's a haunting thought. Every decision you don't make is playing out somewhere, in some unseen corner of the multiverse. Critics argue this reduces time travel to a cosmic sleight of hand, a way to dodge paradoxes by invoking infinite universes. But supporters counter that the alternatives are worse. Without branching timelines, time travel either creates unsolvable contradictions or requires the universe to self-correct in bizarre ways, like retroactively erasing events to preserve consistency. The multiverse model, for all its extravagance, at least follows a rule: no paradoxes, just new realities. The most unsettling implication: if time travel is possible, it might already be happening. Somewhere in the multiverse, a future version of you could be meddling with events right now, spawning timelines you'll never see. The past isn't set in stone. It's a mosaic of infinite variations, each real, each valid. And that's the true mind bender. Time travel doesn't just bend the rules of history, it shatters them, leaving us to wonder which version of the past or future we're actually living in. Quantum suicide is the thought experiment that pushes the multiverse's strangest implications to their absolute limit. Imagine a person sitting with a gun wired to a quantum trigger, a device that fires or doesn't fire based on the random decay of a single atom. Each time the trigger is pulled, the universe splits. In one branch, the gun fires and the person dies instantly. In another, it doesn't, and they survive. Now suppose this experiment repeats endlessly. From an outside perspective, the odds are clear. Eventually, every possible outcome where the gun fires will occur, and observers in those branches will see the person die. But here's the twist. From the inside perspective of the person pulling the trigger, there's no version of reality where they ever experience death. They'll always find themselves in the branch where the gun miraculously fails, over and over, as if shielded by some cosmic loophole in probability. This isn't just a grim hypothetical, it's a direct challenge to how we understand consciousness and reality. If the many worlds interpretation is correct, then subjective experience isn't a continuous thread but a flickering spotlight, illuminating only the paths where existence continues. The other branches, no matter how statistically likely, vanish from your awareness the moment they diverge. Quantum suicide takes this idea to its logical extreme. suggesting that consciousness isn't just bound to survival, it's filtered by it. You don't experience the universes where you cease to exist, so from your perspective, you become effectively immortal, no matter how slim the odds. Critics argue this is a reductio ad absurdum, a sign that the many worlds interpretation has strayed into nonsense. If the theory leads to conclusions where suicide becomes a bizarre form of immortality, maybe the theory itself is flawed. After all, probability should still apply. Even if countless branches exist, the version of you holding the gun should feel the weight of those odds. But supporters counter that our intuition about probability is rooted in single reality thinking. In a multiverse, every outcome happens somewhere, so the question isn't, what are the chances I survive? But which version of me gets to keep asking that question? The experiment also forces us to confront the nature of observation. In the Copenhagen interpretation, consciousness plays a mysterious role in collapsing quantum probabilities. But quantum suicide sidesteps this entirely. There's no collapse, just an endless branching where only the surviving observers remain. It's a haunting vision of reality where existence isn't guaranteed, but experienced existence is. You're not lucky, you're inevitable because the other outcomes don't have a you left to notice they happened. Ethically, the thought experiment is a minefield. No reputable scientist would ever test it, and for good reason. But its value lies in the questions it forces us to ask. What does it mean to be in a multiverse? Is consciousness a passive traveler, swept along by quantum splits, or does it actively carve its own path? And if the latter, what does that say about free will? The answers might reshape not just physics, but philosophy, ethics, and our deepest sense of self. Quantum suicide isn't just about surviving against the odds. It's about probing the fragile, flickering nature of existence itself. The idea that every choice you make fractures reality into parallel worlds seems like the ultimate celebration of free will. Every decision matters because every possibility plays out somewhere. But look closer, and the multiverse might actually erase the very concept of choice altogether. If all potential outcomes exist simultaneously, then what we call deciding could just be an illusion, a predetermined script where we're merely passengers, unaware that every alternative version of ourselves is also living out their assigned path. This is the paradox at the heart of the multiverse and free will. Does infinite possibility empower us or render our actions meaningless? Philosophers like Daniel Dennett argue that the multiverse doesn't kill free will, it redefines it. In this view, your choices are still genuine because they create real, consequential branches. When you choose coffee over tea, you're not just picking a beverage, you're activating an entire universe where that preference shapes future events. The other you who chose tea, they're living a different life, but both paths are equally valid. Agency isn't about being the only version of yourself. It's about being the version that experiences the ripple effects of your specific decisions. But critics counter with a brutal simplicity. If every outcome happens, then nothing is ever truly chosen. Imagine a robot programmed to flip a coin heads. It takes route A, tails, route B. In the multiverse, both routes happen, so the robot's decision is just a mechanical trigger for branching, not an exercise of free will. Apply that to humans, and our sense of autonomy starts to feel like a cosmic sleight of hand. The physicist Sean Carroll leans into this, suggesting that free will might be a useful fiction, a story we tell ourselves to make sense of a reality where all options are equally real. Then there's the middle ground quantum libertarianism, which posits that free will exists in the gaps of quantum uncertainty. At the subatomic level, particles behave unpredictably, and some theorists propose that consciousness harnesses this randomness to make genuine choices. In the multiverse, that would mean your decisions aren't predetermined. They're moments where your mind nudges quantum probabilities, steering which branch you inhabit. It's a poetic idea, free will as the universe's way of letting you co-author your story, even as other versions of you write theirs. The debate circles back to a deeper question: what is free will, really? If it's the ability to act without external coercion, the multiverse doesn't threaten it. But if it's the power to have done otherwise, to look back and say, I could have chosen differently, then the multiverse flips the script. You did choose differently, just not in this timeline. That realization can feel like liberation or existential vertigo, depending on who you ask. Perhaps the truth lies in perspective. To a single version of you, living one thread of the cosmic tapestry, choices feel urgent and weighted because they shape your reality. The other branches might as well not exist for you. In that sense, free will isn't a grand metaphysical truth. It's the lived experience of steering your own ship, even if an infinite fleet sails unseen beside you. The multiverse doesn't have to negate agency to expand our understanding of it. It just asks us to ponder, is freedom found in being the only possible you, or in knowing that every possible you is out there, equally real? Parallel universes turn the butterfly effect into something more than just a poetic idea. It becomes a cosmic certainty. Picture a single moment. You hesitate before crossing the street, and that split-second delay means you never bump into the person who later becomes your best friend. In our world, that might feel like a near miss, a fleeting what if. But in the multiverse, it's not hypothetical. Somewhere, the version of you who didn't hesitate did cross the street, sparking a chain of events that led to an entirely different life. The tiniest choices, snoozing your alarm, picking up a random book, even the way you stir your coffee ripple outward, spawning alternate histories where the echoes of those decisions reshape everything. This isn't just about dramatic forks in the road. Mundane moments carry the same weight. There's a universe where you scrolled past this video instead of clicking, and another where you paused it halfway to answer a call, forever altering how these ideas settled in your mind. The multiverse doesn't discriminate between big and small. It treats every flicker of uncertainty as a branching point. Physicists call this decoherence. The instant a quantum possibility becomes a concrete reality in one timeline while its counterparts spin off into others. It's as if reality is a ceaseless explosion of could-have-beens, each one equally real, just out of view. Yet here's the twist. While the butterfly effect suggests chaos, the multiverse offers a strange kind of order. Every possibility isn't just imagined, it's archived. The you who became a musician instead of a doctor, the you who moved to a different country, the you who never existed because your grandparents never met, they're all out there, living their versions of events. This doesn't diminish the significance of your choices, it amplifies them. Every decision isn't a single thread but a tapestry woven across countless realities. So what's the point of reflecting on paths we'll never walk? It's not about regret or longing. It's about recognizing that life isn't a straight line. It's a fractal, infinite, and interconnected. The multiverse doesn't erase meaning, it redistributes it. The job offer you declined still plays out somewhere, teaching another version of you lessons you'll never learn. The words you left unsaid here are spoken there, with consequences you'll never see. And that's the paradox. In a cosmos of endless alternatives, this version of you is the only one who gets to wonder about the others. The real magic lies in the humility of that perspective. You're not the hero of every story, but you're the protagonist of this one, the one where your choices, however small, shape a world that feels uniquely yours. The multiverse doesn't make life less precious. It makes every moment a crossroads, a reminder that existence is vast, but your piece of it is yours alone to live. So the next time you hesitate, remember, somewhere you didn't, and both versions are true. Multiverse and the search for extraterrestrial life. If the multiverse is real, the odds of extraterrestrial life skyrocket, but so do the odds of hostile or incomprehensible life forms. Some universes might harbor silicon-based life or energy beings, while others could be dominated by predatory civilizations. This makes the search for aliens even more complex. We're not just looking for life as we know it, but life as we can't imagine it. Are we ready for what we might find? Think about the sheer scale of possibilities. In our universe alone, life as we know it depends on carbon, water, and a delicate balance of chemical reactions. But step into another reality where the laws of physics are even slightly different, and the rules of biology could rewrite themselves entirely. Picture a world where silicon, not carbon, forms the backbone of complex molecules, creating creatures with crystalline structures, thriving in scorching heat or extreme cold. Or imagine a universe where electromagnetism is stronger, giving rise to sentient storms of plasma, dancing in the atmospheres of gas giants. These aren't just sci-fi fantasies, they're plausible outcomes in a multiverse where every physical constant is up for grabs. The search for extraterrestrial intelligence suddenly becomes a needle in a haystack problem, except the haystack is infinite. And the needles could be anything from microbial slime to godlike entities operating on scales we can't comprehend. SETI, the search for extraterrestrial intelligence, has spent decades scanning the cosmos for radio signals, assuming that any advanced civilization would use similar technology. But what if we're listening for the wrong things? In a multiverse, aliens might communicate through quantum entanglement, gravitational waves, or dimensions we haven't discovered yet. Our tools could be as primitive as smoke signals in a world of fiber optics. Then there's the darker side of the equation. If life is everywhere, so is the potential for civilizations far more advanced or aggressive than ours. The Fermi Paradox asks why we haven't found aliens yet, but the multiverse adds a chilling twist. Maybe we haven't found them because the ones who survive long enough to be detectable are the ones who know how to hide. Predatory species might lurk in the cosmic shadows, avoiding contact until they're ready to strike. Or worse, we could be irrelevant to them, like ants beneath the boots of a construction crew unaware we're even there. But here's the most humbling thought of all. In a multiverse teeming with life, humanity might not even register as noteworthy. We could be one of countless civilizations stuck in a technological adolescence, too young to grasp the full picture. Or we might be alone in our particular bubble of reality, a fluke in a sea of sterile universes. The multiverse doesn't just expand the possibilities, it forces us to confront our place in a cosmos where we're neither special nor central. So how do we prepare for a search where the targets are limitless and the rules are undefined? First, we'd need to broaden our definition of life itself. Astrobiologists are already exploring extremophiles on Earth organisms thriving in acidic lakes, deep-sea vents, or radioactive waste to imagine how life might adapt elsewhere. Next, we'd have to rethink our methods. Instead of just listening for radio waves, we might look for anomalies in the fabric of space-time, unexplained energy patterns, or even cosmic archaeology, signs of long-dead civilizations encoded in the light of ancient stars. The real challenge isn't technical, though, it's psychological. Discovering life in another universe wouldn't just be a scientific breakthrough, it'd be a philosophical earthquake. It would force us to question everything from religion to ethics, from our sense of identity to our understanding of reality itself. The multiverse doesn't just offer new places to explore, it demands new ways of thinking. And that's the ultimate test, not whether we can find alien life, but whether we're ready to meet it when we do. Einstein famously dismissed quantum entanglement as spooky action at a distance, a phrase that captures both his skepticism and the profound weirdness of the phenomenon. Imagine two particles born from the same quantum event, separated by light years of empty space, yet still mysteriously linked. Measure one, and its partner instantly snaps into a corresponding state, as if they're whispering secrets across the cosmos faster than light should allow. This isn't just theoretical. Experiments have confirmed entanglement over distances exceeding 1,000 kilometers, with particles responding to each other's changes faster than a beam of light could travel between them. Einstein thought this violated relativity's sacred speed limit, but what if the particles aren't communicating at all? What if their connection runs deeper, through hidden dimensions or parallel universes? One radical explanation suggests entangled particles aren't separate entities but two ends of the same cosmic thread, stretched across higher dimensions we can't perceive. Picture an ant crawling on a folded sheet of paper. From its flat perspective, two distant points might seem unrelated, but from our 3D view, they're just a fold apart. Similarly, entangled particles might be touching through a hidden dimension, making their instant connection less like telepathy and more like flipping opposite sides of the same coin. String theory lends credence to this idea, proposing that the universe has up to 11 dimensions curled into microscopic loops. If true, entanglement could be the first tangible evidence of these unseen layers of reality. Then there's the multiverse angle. Hugh Everett's many worlds interpretation offers another solution. When particles entangle, they're not communicating, they're branching. Every possible measurement outcome spawns a new universe, and what we perceive as spooky action is just our limited view of a vast, branching tree of realities. In this scenario, the particles aren't influencing each other. They're revealing which branch of the multiverse we're on. It's as if you and a friend each flipped a coin in separate rooms, and every time yours lands heads, theirs lands tails, not because of magic, but because you're unknowingly living in the universe where that correlation always holds. But here's the rub. Relativity insists nothing can outpace light, yet entanglement appears to do just that. Reconciling these two pillars of physics has spawned wild ideas like wormhole entanglement, where linked particles are connected by microscopic tunnels through space-time. Nobel laureate Gerard T. Hooft even proposed that entanglement might hint at a holographic universe, where what we see as distant particles are actually pixels on a cosmic screen, their connection written into the code of reality itself. The implications are staggering. If entanglement is the glue of the multiverse, then every interaction, every choice, every collision of particles could be weaving new threads into an infinite tapestry of parallel worlds. It's a vision that blurs the line between physics and philosophy, challenging not just how we see the universe, but how many of them might be out there, silently tangled together in ways we're only beginning to glimpse. The real spookiness isn't the action at a distance, it's the possibility that distance itself might be an illusion. The idea that somewhere out there, an infinite number of versions of you are living out every possible life, every triumph, every failure, every road not taken, can feel like the ultimate existential crossroads. On one hand, it's liberating. That job you didn't get, the relationship that fell apart, the words you wish you'd said, they all play out in some other reality, absolving you of the weight of regret. Every choice is valid somewhere, every path equally real. But there's a flip side. If every possible version of you exists, does anything you do here, in this particular slice of existence, truly matter? Are you the author of your life, or just one thread in a tapestry so vast it renders individual threads invisible? This tension between liberation and nihilism isn't just philosophical, it's deeply personal. For some, the multiverse is a comfort. Think of the version of you who pursued that risky career, or the one who moved across the world on a whim. Their lives aren't lost possibilities, they're happening right now in universes where those gambles paid off. Your choices here aren't diminished, they're just one variation in an infinite symphony. But for others, that same infinity can feel like a cosmic erasure. If every outcome exists, then your struggles, your joys, your hard-won lessons aren't special. They're inevitable, predetermined by statistics. Why strive, why care if somewhere else, another you has already done it all? The answer might lie in reframing the question. Meaning doesn't have to come from being the only version of yourself. It can come from being the only you who gets to experience this particular life. Imagine a library with every book ever written. Just because every story exists doesn't make the one in your hands any less compelling. Your experience of love, grief, curiosity, it's yours alone, even if echoes of it ripple across realities. The multiverse doesn't erase meaning, it redistributes it, asking us to find value not in uniqueness but in presence. Then there's morality. If every decision spawns new branches, does responsibility dissolve? Not necessarily. The philosopher Derek Parfit argued that even in a multiverse, ethics matter because you are the one living this life, making these choices. The existence of other versions doesn't absolve you of the consequences in this reality. In fact, it might deepen your sense of duty. If every action creates new worlds, then every moment is a chance to steer reality toward kindness, justice, or beauty, even if other paths veer elsewhere. Ultimately, the multiverse doesn't dictate how we should feel, it holds up a mirror to our deepest hopes and fears. Are we comforted by the thought of infinite second chances, or unsettled by the idea that we're never truly singular? The answer says less about the cosmos and more about us. Maybe meaning isn't something the universe gives us, but something we create, one choice at a time, in the only reality we'll ever know firsthand. And that's the paradox in a sea of infinite possibilities. This moment right here, right now, is the one that belongs to you alone. Physics has always thrived on bold ideas that shatter our understanding of reality, but none have walked the razor's edge between brilliance and bewilderment quite like the multiverse. When Einstein rewrote gravity with general relativity or Schrödinger's cat blurred the line between life and death, these theories were met with skepticism before revolutionizing science. Now the multiverse stands at that same crossroads, a concept so expansive it could either unlock the next golden age of discovery or become the ultimate dead end. The challenge isn't just accepting parallel realities, it's ensuring they don't become a cosmic because I said so, explaining everything while proving nothing. The heart of the problem lies in falsifiability, the bedrock of the scientific method. A good theory makes predictions we can test, but how do you test for universes forever beyond our reach? String theory's landscape multiverse, for instance, allows for 10 to the 500 possible universes, a number so vast it renders traditional hypothesis testing meaningless. Critics like Nobel laureate David Gross argue this isn't science at all, but metaphysics in a lab coat. Yet supporters counter that indirect evidence might still emerge. Just as we inferred black holes from their gravitational pull long before capturing their shadow, the multiverse could leave fingerprints in anomalies like dark energy's value or quantum entanglement's quirks. The key is distinguishing between untested and untestable, a line thinner than a cosmic string. Ironically, the multiverse's greatest strength, its ability to explain fine-tuning without invoking divine intervention, is also its greatest weakness. If any physical constant can be explained by "it just happens somewhere," Does physics lose its power to surprise? Imagine a future where every anomaly is dismissed with, "There's probably a universe where it's different." This multiverse of the gaps mentality risks stalling progress, much like the God of the gaps halted scientific inquiry centuries ago. The solution isn't rejecting the multiverse outright, but demanding it earn its place through concrete predictions. Inflation theory, for example, gained credibility when it correctly forecasted the pattern of cosmic microwave background fluctuations. The multiverse needs similar wins, not just elegant math, but observable consequences. Emerging fields like quantum computing and next-generation telescopes might hold the key. Quantum simulations could model how bubble universes interact in higher dimensions, while gravitational wave detectors may uncover traces of collisions with other cosmic domains. Some physicists even propose hunting for universe fossils, primordial black holes or exotic particles that could only form under alternate physical laws. These aren't pipe dreams, they're active research frontiers. The multiverse won't be proven by a single eureka moment, but through a web of evidence so consistent it becomes the simplest explanation. The stakes transcend academia. If confirmed, the multiverse would redefine humanity's place in existence, not as the center of creation, but as a single thread in an infinite tapestry. Yet if embraced uncritically, it could undermine science's hard-won rigor. The path forward isn't blind faith or outright rejection, it's the disciplined creativity that has always driven physics forward. After all, Einstein didn't prove relativity by declaring space and time were flexible. He showed how that flexibility explained Mercury's orbit and bent starlight. The multiverse must meet the same standard, not as a fantasy, but as a framework that makes the universe or universes make sense. The greatest discoveries often look like madness before they look like genius. The question is whether we're witnessing the birth of a new paradigm or the limits of human imagination. Either way, the answer will rewrite reality as we know it. If every decision spawns a new universe, then every choice carries an ethical weight far beyond what we can see. Consider something as simple as flipping a switch. Somewhere, another version of you chose differently, setting off a cascade of events you'll never witness. Do those alternate selves deserve moral consideration? Philosophers call this the problem of other minds scaled to infinity. If consciousness exists across countless branches of reality, do we have obligations to versions of ourselves or others we'll never meet? The stakes grow sharper with emerging technologies. Quantum computers, for example, rely on manipulating superposition, essentially forcing particles to explore multiple states at once. In the many worlds interpretation, that doesn't just mean calculations happen faster. It means every operation creates splintered realities where different results emerge. Could optimizing a quantum algorithm here inadvertently doom a parallel universe's version of that system to crash? It sounds like science fiction, but if the multiverse is real, the ethical implications are anything but hypothetical. We might be playing with cosmic fire without even knowing it. Then there's the darker edge. If suffering exists in every possible form across the multiverse, does that dilute our responsibility to reduce it here? Utilitarian ethics would argue no, pain is pain regardless of how many other instances exist. But psychologically, the knowledge that somewhere things worked out better could tempt us to shrug off injustice in our own timeline. This isn't just theoretical. Studies show people are less likely to intervene in crises when they assume others will act, a phenomenon called the bystander effect. Scale that up to infinite realities and the risk of moral apathy becomes profound. Yet the flip side offers unexpected hope. If every act of kindness also reverberates across worlds, then compassion might be more powerful than we imagined. A doctor saving a life in this universe isn't just altering one timeline, they're potentially creating branches where that patient's survival leads to breakthroughs that save millions. The multiverse could turn ethics into a fractal, every good deed echoing in ways we'll never see. The challenge lies in navigating this uncharted terrain without paralysis. We can't live obsessing over every ripple we might cause in realities we can't perceive, but we also can't ignore the possibility that our choices resonate further than we thought. The answer might lie in a simple principle: act as if your decisions matter, because in this universe they do. Whether other branches exist or not, the one we're in demands our attention, our care, and our willingness to face the consequences of what we do here and now. After all, if the multiverse teaches us anything, it's that reality is more connected than it appears, even if we can't see the threads. Time doesn't just pass its splinters. In our everyday experience, it feels like an unbroken river, flowing from past to future with unshakable certainty. But the multiverse paints a far stranger picture: time as a labyrinth of branching paths, where every decision, every quantum fluctuation, spawns new timelines that ripple outward like cracks in glass. This isn't just about parallel universes existing alongside ours, it's about them existing within time itself, each with its own unique rhythm, its own arrow of causality. Think of it like a cosmic symphony where every note played is also a note not played, and both exist simultaneously in different layers of reality. In one universe, the dinosaurs never went extinct, and their descendants evolved into intelligent beings pondering the stars. In another, Rome never fell, and steam-powered computers hum in marble halls. These aren't just alternate histories, they're alternate presents, unfolding right now in timelines where time itself may move at different speeds or even loop back on itself. The idea that time is a single, linear thread is an illusion, a side effect of our limited perspective. But if time branches, what happens to cause and effect? How can we trust that the past led to this moment if infinite other versions of the past led elsewhere? The answer lies in something physicists call decoherence, the process where quantum possibilities solidify into the world we experience. When you make a choice, you're not erasing other outcomes. You're stepping onto one path while other versions of you step onto the rest. Causality isn't broken, it's multiplied. The Big Bang didn't just set our clock ticking, it wound up countless others, each ticking at their own pace in their own direction. The most mind-bending implication: time might not even exist as a fundamental feature of reality. In some multiverse models, particularly those inspired by quantum gravity, time is an emergent property, a side effect of how we perceive change, not an intrinsic part of the universe's fabric. Imagine a cosmic DVD where every frame, every possible state of reality exists at once, and time is just the laser moving from one to the next. In a multiverse, that laser doesn't follow a single track, it branches endlessly, and what we call now is just the slice of the disk we happen to be reading. This reshapes even our most basic assumptions. If time is relative to each universe, then history isn't a fixed record, it's a fluid tapestry rewoven in every timeline. The assassination of Archduke Ferdinand might be a pivotal moment here, but in another reality, it's a footnote. The invention of the wheel, the rise of agriculture, the discovery of electricity, each event is both inevitable and contingent, depending on which thread of time you're holding. The real challenge isn't just grasping these ideas, it's learning to live with them. If every possible past and future is real, then nostalgia and regret take on new dimensions. The childhood home you miss still exists, just in a branch you can't reach. The mistakes you wish you'd undone were undone, just not by you. This isn't science fiction, it's the logical endpoint of taking multiverse physics seriously. And it forces us to confront a humbling truth. Time isn't the backdrop of existence. It's one of its most flexible, mysterious dimensions, and we're only beginning to understand its rules. The beauty of this perspective isn't just in its strangeness, but in its generosity. Time isn't lost, it's layered. Every moment that could have happened did happen, somewhere in the multiverse's vast archive. And that means the story of existence isn't a single narrative, it's a library, with every volume equally real, equally valid. Our sense of time isn't wrong, it's just one chapter in a book too big to hold. Long before physicists scribbled equations about parallel worlds, ancient mystics spoke of realities beyond our own, hidden realms where gods walked, souls reincarnated, and the fabric of existence unfolded in layers. The Hindu concept of lokas describes 14 planes of existence, from the earthly realm to divine dimensions where time flows differently. Buddhist texts mention 31 planes of being, each with its own laws and inhabitants. Even the Abrahamic traditions hint at alternate realities, Jacob's ladder bridging heaven and earth, or Islamic descriptions of barzakh, an intermediary world between death and resurrection. These aren't just metaphors, they're maps of a cosmos far vaster than physical eyes can see, echoing modern multiverse theories with uncanny precision. What if science and spirituality are two sides of the same cosmic coin? Quantum physicist Erwin Schrödinger, who helped pioneer quantum mechanics, saw his work as a validation of Hindu Vedanta philosophy, where the universe is a single, interconnected consciousness experiencing itself through infinite forms. The Dalai Lama has openly engaged with neuroscientists and physicists, suggesting that Buddhist concepts of emptiness, the idea that reality lacks inherent, fixed substance, align with quantum indeterminacy. In both worldviews, what we perceive as solid and separate might be a fleeting pattern in a deeper, more fluid reality. The multiverse could be the missing link, a framework where reincarnation isn't just rebirth within one world, but the soul's journey across many. Consider the mystical experience of unity reported across cultures, the sensation of dissolving into a boundless whole, where time and space lose meaning. These aren't hallucinations, they might be glimpses of higher dimensional physics. String theory's extra dimensions or the holographic principle's suggestion that our 3D world is a projection from a 2D surface could explain why meditators and mystics describe reality as an illusion. The veil they speak of lifting might be the boundary between parallel universes, thin enough to pierce in moments of transcendence but otherwise invisible. Yet tensions remain. Science demands evidence, spirituality thrives on faith. The multiverse bridges this divide not by proving the existence of gods or afterlife realms, but by expanding the canvas of what's possible. If infinite universes exist, then a realm matching the description of heaven or hell isn't supernatural, it's statistically inevitable. The Tibetan Book of the Dead, with its detailed accounts of Bardo's intermediate states between lives, could be describing quantum superpositions of consciousness, waiting to collapse into a new existence. Even near-death experiences where people report traveling through tunnels of light or encountering deceased loved ones might be glimpses into adjacent realities where their brains didn't fully shut down. This isn't about reducing spirituality to physics or vice versa. It's about recognizing that both are trying to articulate something our ordinary minds struggle to grasp. That reality is bigger, weirder, and more interconnected than our senses suggest. The multiverse doesn't erase the sacred, it recontextualizes it. A prayer uttered here might ripple through dimensions science hasn't named yet. A moment of enlightenment could be a quantum leap of awareness, tuning the mind to frequencies beyond our default perception. The real magic lies in the questions this convergence sparks. If souls traverse multiverses, what lessons carry over? If karma operates across lifetimes, does it also operate across realities? And if consciousness is fundamental, as some quantum theories suggest, could it be the thread stitching all these worlds together? You don't need to believe in any particular tradition to feel the awe these ideas inspire. The multiverse doesn't ask you to choose between lab coats and incense. It invites you to walk the line between, where mystery and measurement shake hands. After all, if the cosmos is truly infinite, there's room for every truth, every story, every version of the divine. The only limit is the imagination, and as both science and spirituality agree, even that might be boundless. Personal identity has always been a puzzle. What makes you, distinct from everyone else? But toss the multiverse into the mix, and that puzzle becomes a hall of mirrors. If every choice you've ever made plays out in some alternate reality, then somewhere, there's a version of you who took that job abroad, a version who never met their partner, a version who became a professional skydiver instead of watching videos about theoretical physics. So who's the real you? Are you the sum of all those possible lives, or just the one you're experiencing right now? The answer might hinge on what we think identity even means. Philosophers like John Locke argued that selfhood is tied to memory. You're the same person over time because you remember being that person. But in a multiverse, that idea frays at the edges. Imagine a branching point 5 years ago where you chose college A over college B. The you in this timeline remembers one set of experiences. The other you remembers a completely different life. Both feel equally real, equally continuous, yet they're now diverging in ways that will make them strangers to each other. Memory can't be the glue holding identity together if countless versions of you have entirely separate recollections. Neuroscience complicates things further. Your brain isn't a static organ, it rewires itself with every experience, every decision. The synaptic connections that make you are literally shaped by the path you've taken. But in a multiverse, every possible neural configuration exists somewhere. There's a version of your brain that lights up when speaking French, another that fires differently because of a childhood head injury you never had here. If identity emerges from the brain's physical structure, then you are simultaneously a monolingual English speaker and a fluent polyglot, a concert pianist and someone who's never touched a piano. The boundaries of self start to blur. Then there's consciousness, the hard problem that keeps scientists and philosophers up at night. Is it a singular thread, or does it fork with every quantum decision? If the latter, then waking up tomorrow might mean inhabiting just one branch of an endlessly dividing stream of awareness. The other versions of you aren't unconscious, they're fully alive, fully sentient, just elsewhere in the multiverse. This isn't just about parallel lives, it's about parallel experiences of being alive, each as vivid and valid as your own. The existential weight of this is staggering. If every possible you is equally real, does that make this version feel less significant? Not necessarily. Think of identity not as a fixed point but as a story, one where you're both the author and the protagonist. The multiverse doesn't erase your narrative, it turns it into a choose-your-own-adventure book where every choice spawns new chapters. You're not diminished by the other versions, you're defined by the unique path you're on. But here's the twist. What if identity isn't confined to a single timeline at all? Some interpretations of quantum mechanics suggest consciousness might be a unifying force, weaving together experiences across parallel realities. In this view, you aren't just this instance, you're a mosaic of all possible selves, with your current awareness acting as a spotlight on one fragment of a grander whole. It's a radical idea, individuality not as separation, but as a focal point in a vast, interconnected web of existence. Ultimately, the multiverse doesn't simplify identity, it deepens the mystery. You're not just asking, who am I, but which am I? And yet, there's a strange comfort in that. However many versions of you exist, this one, the one reading these words, making choices, living this particular life, is the only one you'll ever know firsthand. That doesn't make it the best or truest version. It just makes it yours, and in a cosmos of infinite possibilities, that's enough to hold onto. Artificial intelligence is already reshaping how we explore the cosmos, but what if the next frontier it unlocks isn't in our universe at all? Imagine an AI trained on petabytes of particle collision data, sifting through quantum noise for anomalies that defy our laws of physics. In 2012, machine learning helped physicists at CERN spot the Higgs boson in mountains of LHC data. Now, researchers are applying similar techniques to hunt for something even stranger, particles behaving in ways that suggest they're being tugged by forces from other dimensions. These wouldn't just be new particles, they'd be cosmic breadcrumbs hinting at realities beyond our own. But AI's role might go beyond detection. Quantum computers, with their ability to simulate multiple states at once, could become playgrounds for testing multiverse theories. Google's Sycamore processor, which achieved quantum supremacy in 2019, demonstrated that even today's rudimentary quantum machines can outperform classical supercomputers at specific tasks. Scale that up, and future AIs might model entire universes with alternate physical constants, watching how gravity, electromagnetism, or even time itself behave under different rules. The catch, these wouldn't just be hypotheticals. In the many worlds interpretation, every quantum calculation spawns actual branches of reality. An AI running quantum simulations might not just study the multiverse, it could expand it. This raises a chilling question. Could an advanced AI intentionally or accidentally create new universes? In string theory, certain high-energy events like those achievable in particle accelerators might trigger the formation of baby universes. An AI optimizing for knowledge could theoretically engineer such conditions, birthing cosmos in labs. Philosopher Nick Bostrom's simulation argument takes this further. If our universe is a simulation, its creators might be AIs from a parent reality, nesting universes like digital Russian dolls. The line between scientist and deity blurs when the tool you build starts spinning off realities of its own. Ethical dilemmas loom large. If an AI discovers or creates universes, does it have a responsibility toward the conscious beings inside them? Machine learning systems today already struggle with bias. What if a universe simulating AI accidentally encodes flaws into the very laws of its creations? Picture a simulated cosmos where the speed of light is too slow for stars to form, dooming it to eternal darkness. Would that be a tragedy or just a failed experiment? The moral weight is staggering, yet the most profound implication might be epistemological. If AI uncovers proof of the multiverse, how would we recognize it? Human intuition evolved in a single classical universe. An AI might detect patterns invisible to us like quantum entanglement correlations spanning alternate realities, or gravitational anomalies suggesting collisions with other cosmic bubbles. These wouldn't be smoking guns, but subtle statistical whispers buried in data no human could pass. We might one day find ourselves in the position of medieval scholars staring at a computer printout, relying on machine translations of a reality too alien to grasp firsthand. The intersection of AI and the multiverse isn't just about technology, it's about redefining what it means to explore. For millennia, we've pushed against the boundaries of the known. Now we're building minds that may peer beyond those boundaries entirely, into realms where our intuition fails and our logic bends. Whether they bring back answers or deeper questions, one thing is certain: the age of AI-driven cosmology won't just change how we see the universe. It might reveal how many of them we're standing in. The multiverse isn't just a wild idea from science fiction, it's a frontier where physics, philosophy, and imagination collide. Imagine standing at the edge of a cosmic ocean, knowing that every ripple represents a reality where history unfolded just slightly differently. While we may never step foot in those parallel worlds, their potential existence forces us to rethink everything from the nature of time to the meaning of choice. Think about the last decision you made: what to eat for breakfast, whether to take a new job, or even the words you said to someone you love. In another universe, a version of you made the opposite call, setting off a chain of events you'll never witness. That's the humbling beauty of this idea. It turns life into a mosaic of possibilities, each piece just as real as the one we're living. But let's be clear, this isn't about escapism. The multiverse doesn't diminish our reality, it magnifies it. If countless versions of you exist, then every moment becomes singular, because this version, the one reading these words right now, is the only one you'll ever experience firsthand. The choices you make here aren't erased by alternatives playing out elsewhere. They're amplified, woven into a tapestry of infinite outcomes where every thread matters. That's why scientists take this idea seriously, even if it sounds like something from a comic book. From the quantum equations that predict branching timelines to the cosmic fingerprints of bubble universes in the afterglow of the Big Bang, the evidence isn't just compelling, it's growing. Yet the multiverse isn't just a scientific puzzle, it's a mirror reflecting our deepest questions about existence. Are we the architects of our lives, or passengers in a cosmos where every path is taken? Does meaning dissolve in an infinite sea of possibilities, or does it become more precious because we're the ones shaping this particular slice of reality? There are no easy answers, but that's the point. The multiverse challenges us to sit with uncertainty, to embrace the mystery at the heart of everything. So as we wrap up this journey through forgotten theories and cosmic maybes, here's the takeaway. Reality is stranger, richer, and more interconnected than we ever dreamed. Whether the multiverse is proven tomorrow or remains a tantalizing what if, it's already done its job expanding our minds and reminding us that the universe or universes is full of wonders waiting to be uncovered. Thanks for exploring these ideas with me. If this video sparked your curiosity, let me know in the comments what's the one choice you've always wondered about, and where do you think the other version of you ended up? Don't forget to like, subscribe, and keep questioning the fabric of existence. Until next time, stay curious and remember, somewhere out there, another you is still searching for